Are you seeing the screen in full screen?
Yes, we are.
All right, cool. All right, so my name is Jean Lapierre. Thank you for the introduction, Wes. I'm indeed the Senior Director of Advanced Technology for Matrox. But for those that don't know me, let me introduce myself a little bit. I started at Matrox right out of university many moons ago. I always worked in video. I worked in developing post-production and broadcast equipment based on PC technology with add-in cards since my very first day at Matrox. When I started, we were dealing with composite video and standard definition, saw the transition to SDI, to HD, and now to UHD. I've been involved with the development of ST2110 and NMOS at Matrox for several years now. I also helped the JTNN tested program, but more recently I got involved with our IPMX efforts, and I'm currently co-chair of the VSF IPMX working group. You have to understand that Matrox makes these broadcast equipment, but we also have divisions that do a lot of work in the Pro AV space. And so today I'd like to talk about IPMX and how I think IPMX can be used by broadcasters. Before I get started, I'd like to point out that IPMX is still a work in progress, and that things are evolving pretty quickly in our industry. But I'm confident, however, that what we'll discuss today is accurate and should match your experience with IPMX device. So let's start by talking about IPMX and why it was created. IPMX was born from an idea of AIMS that AIMS should promote the use of ST2110 for the Pro AV space. In the Pro AV market, they're also migrating to the infrastructure to AV over IP. But unlike in broadcast, there's no true open standard in Pro AV for AV over IP. So a SMPTE standard like ST2110 seems like a great idea. NMOS is also involved in the sense that it helps cover functionality required to have a complete set of standards for the Pro AV space. But however, there's a few areas where the needs of the Pro AV market require a few tweaks. So IPMX was created to regroup a suite of specification and recommended practice that address the Pro AV space. So let's take a quick look at IPMX. IPMX is based on SMPTE ST2110. It supports 2059 PTP. The RTP signal generated in IPMX are based on the ST2110 suites of specifications. IPMX also uses AMWA NMOS. It uses ISO4 for registration and discovery, ISO5 for connection, ISO8 for audio channel mapping, the newly created IS11 for EDID management, and NMOS security and other best common practice found in NMOS. But now let's look at some of the tweaks that IPMX adds for Pro AV. The PTP profile and timing accuracy mandated by IPMX are designed to make it easier to implement a grandmaster. For example, the default IPMX profile generates about 32 times less traffic than the default one for ST2110. And that means less load on the grandmaster, but also less load on the network. And so for IPMX, there's less need for network equipment with special support for PTP. IPMX is also designed to support workflow where there's no PTP at all. All right, so in IPMX, we support PTP, but there's a lot of workflow in the Pro AV space that don't require us to use PTP on the network, and that's also an advantage. Even though ST2110 supports asynchronous sources, there's no, it's not very typical of an ST2110 installation, and in which most sources are asynchronous. In IPMX, however, asynchronous sources are the norm, and additional tweaks are provided to accommodate this. And Pro AV is crucial to support very low in-to-out latency. And IPMX adds some control to enable the user to optimize the latency in their system. So new tools are also introduced by IPMX to address specific Pro AV needs. HDCP, for example, it's the copy protection scheme used to encrypt signals carried over HDMI, DisplayPort, and DVI connections. Pro AV makes extensive use of devices with HDCP encrypted material. And so IPMX is developing a standard for carrying such signal over IP using RTP. Pro AV, in Pro AV, not everybody's concerned with the occasional drop packet. So, but among those that are, the cost of a ST2110 installation is not always something that they can afford. And so IPMX introduces a new forward error correction techniques that support very low latency and better than those that are currently supported by ST2110. And Pro AV space support for existing infrastructure is absolutely critical. And things like supporting gigabit network or Cat5 cable is very important. Most IPMX installation are expected to actually be a compressed video installation where ultra low latency codec with high quality, capable of carrying video over a gigabit network is part of IPMX. So with that introduction, let's look at why I think IPMX is interesting for broadcasting. Especially those that are already deploying ST2110 in their installations. So one of the main drive for ST2110 and IPMX is to be able to use IT infrastructure equipment that's available off the shelf instead of using traditional custom broadcast or even custom Pro AV equipment. The goal is to benefit from the economy of scale and also the added flexibility of IP. So I think it's important to note, though, that the Pro AV market is a lot bigger than the broadcast market. There's a lot more Pro AV sites out there and also a lot more manufacturer of Pro AV equipment. So there's a wide range of equipment prices and functionality available in the Pro AV space. And, you know, it's like how less expensive HDMI monitor are used in broadcast today. I think IPMX will also be used in broadcast, but it's easy to see that broadcaster did not replace every SDI monitor in their facility by HDMI monitor. So I think what we'll see is a mix of ST2110 and IPMX devices used in broadcast. It will, like for HDMI monitor, depend on the use case and the problem the broadcaster is trying to solve. So with that, let's look at IPMX and what it can do for broadcaster. I've been asked about the compatibility between IPMX and ST2110 on many equations recently. So let's look at this in detail because I think it's very important that everybody understands what IPMX can do and when it can be used with ST2110 equipment. Hopefully, this make it easier to understand how IPMX devices can be used in broadcast, especially in broadcast ST2110 networks. So as we saw earlier, IPMX supports PTP and it has its own simplified profile. But IPMX also mandates that the PTP profile used by ST2110 also needs to be supported by all IPMX followers. So this is actually a shall in the specification. So what that means, it means that you can add an IPMX device to a ST2110 network that already has a ST2059 compliant grandmaster without any issue. You don't need to add anything specific for the IPMX device. Just add it to the network and it will use a grandmaster that's there. Now, the next thing is that IPMX is based on ST2110. It's based on the RTP protocol of ST2110. So the IPMX network protocol is compatible with the ST2110 devices. So when IPMX devices are in a ST2110 network, they can interoperate with ST2110 devices. As we saw, IPMX is also based on AMO NMOS, and this means that IPMX devices are discovered and their signal can be routed and controlled the same way an ST2110 device are. So your existing broadcast controller, if it uses ISO4 and ISO5, it can be used with IPMX devices without needing any modification. It's possible to mix and match IPMX and ST2110 devices in an ST2110 environment, like I have in my diagram. However, IPMX does add some tweaks and some new functionality in order to support additional workflow required by ProAV. And some of these functionality may cause some limitation to the interaction between IPMX and ST2110. So we can't always have our cake and eat it too, unfortunately. So let's look at all this in more detail and hopefully clear things up. All right. Let's look at a typical ST2110 network in broadcast. So in a broadcast environment, everything's usually gen-locked to a reference, and all the signal coming into an ST2110 sender are aligned with PTP. In my diagram here, we can see that there's a PTP grandmaster feeding into our network, but that's also generating typically generating the black burst that would use by the facility. So all the signal coming into our the SDI signal coming into the ST2110 converters, for example, would already be locked to PTP and aligned with the epoch. So if we add a IPMX device to this network and we feed the same SDI signal to our IPMX sender, it will actually generate a signal that, because the source is aligned with the epoch, what I call a synchronous signal, because it's receiving a synchronous signal, it will generate a 2110 compliant signal on the network. It'll look like any other ST2110 device, and the signal will then be able to be received by any ST2110 receiver or IPMX receiver. IPMX receiver will be happily receiving the signal from any ST2110 sender without any issue. But in ProAV, we have what's called a synchronous signal. ProAV signals are most often an asynchronous signal. And what I mean by that is, for example, if you have this laptop here that has a DisplayPort output, that laptop is not gen-locked. So IPMX mandates support for asynchronous sources. It's important to understand that ST2110 also defines how asynchronous sources should be handled, type thing. Unfortunately, it's not mandatory in the specification to support asynchronous sources, but it is mandatory for IPMX. And so if we look at what happens when we add this source that is asynchronous to our network. So in this case, a laptop with the DisplayPort output, obviously this laptop, like I said, is not gen-locked to anything. So the IPMX sender will generate an RTP stream that's not locked to epoch, like what is typical of other ST2110 signals. The IPMX receiver will be able to reproduce the signal from the laptop as if the laptop was connected directly to a monitor. There won't be any skipped or repeated frame, and we'll be able to do very low latency. That's what the main goals are for IPMX. if we have an ST2110 receiver, well, I think that most ST2110 device will successfully receive that signal actually. But what the video will look like will depend really on the implementation of that ST2110 device. So on a software multi-viewer, for example, the result will probably look like any other ST2110 source would look like on that multi-viewer. Other devices might apply some kind of TBC to the signal before displaying it or using it or consuming it. But some might look at the some other devices might look at the SDP file and recognize that this is not a synchronous signal and refuse to connect because they're not designed to support that use case. One thing that is important to understand here is that if we had used an ST2110 sender that does support a synchronous signal and we had fed an asynchronous signal to it, like is described in the 2110 spec, and it would generate a signal very similar to the one from the IPMX sender in this case. And the result at the output of the ST2110 receiver would be the same as it was for the IPMX sender. Okay, so like we mentioned before, support for HDCP source is important in the Pro AV space. And HDCP is not really part of any of the ST2110 spec. And so if we're using HDCP encrypted media source for our PMX sender, like in this example I'm giving here, we shouldn't expect the ST2110 receiver to be able to successfully receive that signal. But that signal can be carried over this ST2110 network, not a problem. And if we have an IPMX receiver that supports HDCP, then we can expect it to be able to reproduce the signal without any issue. So there's definitely some use cases where IPMX sender will produce a signal that a ST2110 receiver won't be able to receive. So if we do a quick recap, if we have an IPMX sender and receiver, they'll work fine in a ST2110 environment. They don't need a separate grandmaster or anything. They will use the grandmaster that's provided. The IPMX receiver will work with any ST2110 device source signal, no problem. ST2110 receiver will definitely work with an IPMX sender if that IPMX sender is connected to a synchronous source. It might work with IPMX or ST2110 senders that have a synchronous source. It'll depend on the implementation because it's optional. And definitely, if we use existing ST2110 devices out there, I don't expect these devices to be able to receive a signal that is protected by HDCP because this is a new gadget that IPMX brings to the table. All right, hopefully this was clear and helps you understand when we can use or not use IPMX devices with ST2110. I would say most of the time it's not a problem. So let's look at a little bit of example here of how a broadcaster might benefit from IPMX in their installation. So like we mentioned before, IPMX targets media sources like computers, set-top boxes, and other devices that use HDMI, DisplayPort, and DVI connection. So if you need to interface with these types of signal, IPMX might be a good solution. So it might be difficult to find an ST2110 device, let's say today, that supports, I don't know, DVI or DisplayPort. And should be fairly easy to find IPMX devices that do that. So you'll need to be careful, however, for your actual workflow. Here's an example we have of a computer source. And if we intend to use that signal with an ST2110 device receiver, you'll need to make sure that that device supports asynchronous signals. In the case of a IPMX receiver that drives a DisplayPort like we have here though, we saw that this should always work no matter if the source is ST2110 or IPMX. And now we're able to connect a DisplayPort monitor to our 2110 network and monitor some signals with it or receive signals and use them with that monitor. It's a very good example of a simple use of IPMX in a broadcast setting. So another case I think that might be very useful to realize is that sometimes broadcasters, they need to use those set-top boxes to monitor a TV channel. Maybe they're monitoring their own TV broadcast or other broadcasters' signal, and set-top boxes are typically used to do that. And with the use of IPMX devices, the ST2110 network they have can be used to distribute this signal anywhere in their facility. Of course, typically these set-top boxes have their output HDCP protected. And so they'll require the use of a HDCP enabled device on both ends. If like in our example here, the output of the set-top box is protected. And so you'll need an IPMX receiver to drive a monitor and things like this. What's really cool though, or at least I thought it's cool, is that HDCP, the support, how it's done, it's added as a separate spec, if you like. It's kind of a generic way of doing HDCP over IP. It's not specific to IPMX itself. So a device manufacturer, an ST2110 device manufacturer, could decide to add support for HDCP to their device. And so in this case, if you did that, oh, I think I have the wrong slide here, I'm sorry. Oh no, it's sorry. So it's correct. And so in my example here, instead of having to use a IPMX receiver in order to drive a monitor, maybe the manufacturer of the multi-viewer, which are often using, an HDMI monitor for their output, and HDMI monitor typically support HDCP. So it would be technically possible for the multi-viewer manufacturer to add support for HDCP to their device in the same way an IPMX device can add support for HDCP. And maybe that's a new workflow that could be enabled where broadcasters that need to monitor, set-top box signal that are typically encrypted with HDCP could do that using a multi-viewer where the functionality for the support of HDCP has been added. Video wall are also very common in Pro AV, and lots of companies make video wall for the Pro AV space, but they're also useful for the broadcasters. Broadcasters actually use traditional Pro AV video walls today in their studios to do various things. And with IPMX, they can use the next generation of IPMX video wall and simply connect them to their ST2110 network. What's really interesting is that, as we saw, an IPMX device can be used with both ST2110 signal and an IPMX signal. So by using a IPMX-based video wall in their studio, all of a sudden it becomes very simple to drive any signal that's present in the facility on their ST2110 network and drive it to that video wall. It would even be possible actually to synchronize all the monitors to the house sync through PTP, if that's even still a thing. All right, another area that's interesting to look at is I predict that IPMX will get picked up as a very attractive technology to use for an IP KVM device. So KVM are used today by broadcasters, but having a KVM that uses signals that are compatible with ST2110 might actually be very compelling. New workflow enabled by AV over IP might be easier to deploy because of IPMX and ST2110. And so broadcaster can use an IPMX-based KVM and just carry the signal for that KVM over the network, their ST2110 network, and do that. That's one way of using it. But what's interesting is the video and audio of that KVM could also be used as a video feed anywhere ST2110 source would normally be used, maybe for training or review or even directing, because you could use a broadcast multi-viewer or an IPMX receiver to monitor the video and audio from that KVM. So anyway, use your imagination. I think it enables some new some new things we can do. Last thing, well, not last, but the next thing I'd like to cover is because IPMX target different compression ratio than broadcast because of the Pro AV space. Pro AV requires support for gigabit network. It's so Pro AV, you know, we want to be able to carry 4K video over something like 800 megabit, HD video 200 megabit. Much lower ratio than what's typically used in broadcast. And so what that enables is all of a sudden maybe monitoring using a laptop becomes possible. So I think it would be really cool to take the output of the multi-viewer, feed it to an IPMX sender that would send it over the 2110 network using a bandwidth that's small enough so you could connect your laptop to that 2110 network and receive that signal, and also then use laptops to monitor what's typically needs a ST2110 converter driving 2110 HDMI monitors to do. So also then we can use software and laptops to monitor things all over the place. It's kind of cool. Again, this is just about the compression ratio that we're using in IPMX, and maybe the device manufacturer of current 2110 device could pick up that technology and add support for it, so they could skip the HDMI to IPMX converter and drive that signal directly onto the 2110 network in the broadcast environment. All right, so takeaway I would like you to remember about this is that IPMX device can be used in a broadcast ST2110 network. IPMX is discovered, managed, routed the same way as ST2110 equipment is. So you don't need a separate controller. You can use your existing controllers to do that. It's easy, therefore, to integrate IPMX into your existing infrastructure. Some IPMX device might not work with existing ST2110 receiver, like I mentioned, if it's HDCP protected or if it's asynchronous and your receiver doesn't support asynchronous signals. Use IPMX device to solve real broadcasting problems. Some technology, I think, introduced by IPMX could be added to broadcast equipment like we saw, and it might enable new workflow for broadcasters. And with that, I thank you very much.